All right, today we will have a short lesson on applying polynomials to geometry-related shapes and figures. All right, so let's think about things that we already know. We already know that you have formulas for area and volume. So the area of a triangle is 1/2 base times height. The area of a rectangle is base times height. So there's a set of formulas that you already know. We have recently learned how to add, subtract, and multiply polynomials. So basically today we are going to combine these two skill sets together and apply them to some geometry shapes. All right, so let's take circles for example. When I say, all right, if I was going to do this and I wasn't sure what I was doing, the first thing I'm always going to do is write my formula down. So I know the formula for area of a circle is pi r squared. So when I look at my picture, my radius is 4. So I'm going to take 4, and plug it in for r. And this is going to give me 16 pi centimeters squared. For today, I want exact answers. You do not need to get a calculator out, so just leave your answer as 16 pi, and we will roll with that. Okay, so now I'm going to translate that to a circle where the radius has a variable in it, 6t cubed centimeters squared. So same thing, just start with your formula. Your area is pi r squared. When I look at this, I know now that my radius is 6t cubed, and I'm going to square that because I'm taking out my radius right here, so I'm taking out this r, and I'm putting in 6t cubed. So now 6 times 6 is 36. T cubed squared, power to a power, you multiply those exponents, is t to the 6. And then I have my pi, and you always want to attach your units. So the process is the same. You just have to apply the properties of exponents when you take 6t cubed squared. All right, similar with rectangles. So we learned in elementary school that the area of a rectangle was length times width, or base times height, whichever formula you prefer to use. So here we have, and I'm going to put units with this just to kind of show you a different perspective. You have 5 feet times 10 feet, which is going to give you 10 times 5, which is 50, and feet times feet gives you feet squared. And we are done. So now when we look at the second problem here, we're going to take this same concept and we're going to transfer it to another rectangle. So again, my formula is length times width, or base times height. This time my length is 4g minus 5, and my width is 2g, or vice versa, however you want to think of it. So now I have a binomial times a monomial. So I'm going to take my 4g times 2g, which is going to give me 8g squared. And then I'm going to take my 5 times my 2g, bring down my negative, and I have 10g. And feet times feet is going to give me feet squared. Same exact process, but now I just have a monomial times a binomial instead of two numbers. All right, volume. If you think back to volume, the volume of a rectangular prism is length times width times height. Because this is specifically a cube, you know that all three sides are the same. So if this side is 3 feet, this side is 3 feet, and this side is also 3 feet. So in this particular case, you're going to take 3 feet times 3 feet times 3 feet, which 3 times 3 is 9. 9 times 3 is 27. So this is 27 feet cubed. Because this is a cube, you could have also said, hey, the volume is the length of the side cubed, which would have been 3 cubed, which would have also been 27. So again, how does that change if I have a variable? The process doesn't change. This is still going to be length times width times height. Since one side is 5x and this is a cube, that means all three sides are 5x. So I simply have 5x times 5x times 5x. 5 times 5 is 25. 25 times 5 is 125, and x to the first times x to the first times x to the first will give me x cubed, and my unit in this particular case is going to be feet cubed. All right, on to the last problem. Basically, this is like a donut. So if you think of how they make a donut, they basically take a big circle of dough, and then they cut a little circle of dough, and then they take this little circle of dough and they totally remove it. So they take it away from the problem. So if we think of what's going on in this problem, we're taking the area of the big circle, and we're going to subtract the area of the smaller circle. Okay, so if we think about applying that same concept to any shape, anytime we're removing an area, we're just taking the area of the big piece and we are subtracting the area of the little piece. So let's do these rectangles. All right, so I'm going to take the area of my big rectangle and I'm going to subtract the area of my small rectangle. The area of my big rectangle, I'm going to use capital letters, is length times width. The area of my small will be the small length times width. So here's big length, big width. So I have 12 times 5 minus 3 times 2. 12 times 5 is 60 minus 6. So the area here, shaded area here, is 54 feet squared. If I look at transferring the same knowledge, it's the same thing. It's going to be the area of the big rectangle minus the area of the smaller rectangle. So I'm going to take my big length, x plus 5, times y plus 2, and I'm going to subtract x times y. I have a binomial times a binomial, so you can either use the box method or double distribute. I'm going to choose to double distribute on this particular problem. So I'm going to take this times this. So I get x times y plus 2x. And then I'm going to come down here and I'm going to take this times this. So now I get plus 5y plus 5y, so you can see that, plus 2. And then I'm going to subtract the x times the y. So if I look at what's going on now, I look for like terms. I have a positive xy here and a negative xy here. So this is really 2x plus 5y plus 2. These two terms cancel, and the unit for this particular thing, we're finding area, so this is going to be in feet squared. This is what you need to know for today. So if you will go to your packet and go to the worksheet for F9, you probably need to show your work in your composition book, and when you are finished, I need you to upload your work and your answers to Canvas. Have a great day, and I will see you tomorrow.